Hi and welcome to Maths class. We're still looking at the binomial distribution, and today we're going to look at some new concepts that we haven't explored yet in this section on probability, and those concepts are expectation and variance. So before we get started, I just want you to think about this question. I have a normal six-sided die and I roll it 60 times. Now, we know that there are a lot of different things that can happen, right? But what would you expect as a kind of, if you really had to guess, if you had to put your money on it, how many times would you expect to roll a 5? So I don't know how you thought about this question, but this is the way I think about it. I've got a 1/6 probability of rolling a 5, and I'm going to roll 60 times. So every time I roll, I've got a probability of 1/6. Okay, so that's going to give me 10, about 10 5s. Another way of thinking about this is every six rolls, I'm going to get about one roll of the 5, okay, every 6. And there are 10 lots of 6 in my 60, right? But I want you to think about it this way. The probability is 1/6, and I'm going to do it 60 times. So what we're talking about here is a thing called expectation. What is the expected value for x? I'm just going to go back to this question again. If x is the number of rolls, okay, if x is the number of times I rolled a 5 in 60 rolls, then I would expect about 10 5s out of 60 rolls. Now we know that it's going to be a probability of less than a half that that's actually going to happen, but it's still going to be the most likely outcome, right? So what we're looking for is the most likely outcome, and the most likely outcome is that I get a 10. I get 10 5s in my 60 rolls. So the notation there is E of x, capital E, and in brackets my capital X is going to be 10 because I'm expecting x to be 10. So in general, if I've got a binomial distribution and a roll of the die is a binomial distribution, if I'm looking for a particular number, either a 5 or not a 5, that means there are two outcomes, right? So if I roll a dice, the probability, the number of rolls I had before was 60. The probability of success was, oops, can't write a decimal, I've got to write a fraction, was 1/6. And what I did was multiply those two things together. So the expected value for any binomial distribution with n trials and the probability of success being p is going to be n times p. So if you're having trouble, remember this, go back to your dice rolls and think about that. So that's expected value. And I think the expected value is something we can reasonably kind of understand what it means. The next thing we're going to look at is a concept called variance. Now, first of all, I'm just going to talk about how to calculate it. Okay, I'm just going for another minute to talk about expected value. The important thing to understand about expected value is it is a kind of measure of centre. Now, we've seen measures of centre since about year 9 when we've started to do statistics and you learnt mean, median and mode. So all those three things are a way of looking at what an expected value might be. So if I've got some data and I look at the numbers, and let's say it's, the number of sick days that an employee took, and I can see that the mean is 2 and the median is 2, then I think the most likely number of sick days taken is 2, okay? There'll be a spread, right? There'll be lots of people with 1 and lots of people with 3, but the most likely is going to be 2, and that's our measure of centre. That's what expectation is. So the other thing that we do is we actually call expected value the mean, and we give it this symbol mu, okay? We call that mu. It's a Greek kind of M. So let's just talk a little bit about variance and standard deviation and what they are. So if expectation is our measure of centre, then variance and standard deviation are our measures of spread. They're both measures of spread and they are very closely related to each other. The best way to understand standard deviation is as the average distance of any value from the center. So if I take every single value and I average out how far it is from my expected value, then that's going to give me the standard deviation. Typically, we can find most values in within a distance of 1 standard deviation from the center. So if my center is 5 and my standard deviation is 1, then most of my values, probably, possibly about 3/4 in some examples, will be either 4 or 5 or 6. So either the center itself or within a distance of 1 from the center, which is the 4 and the 6. All right, that's what our standard deviation is. Variance is a little bit harder to understand exactly what it is, but it's just another measure of spread. It's basically the standard deviation squared. It's another measure that you'll be asked to calculate. And we have formulas for these. So variance is just NPQ. Now, if you remember, expected value was NP. Variance is NPQ. So we just take our expected value and multiply it by Q. Standard deviation is the square root of that. So quite often we calculate variance as a step towards calculating standard deviation. There is another symbol for standard deviation, and that is this sigma. All right, you might see that used as well, and that's our measure of spread. Okay. A fair die is rolled 15 times. Find the expected number of threes. So the first thing I'm going to look at here is I've definitely got a Bernoulli sequence. I'm rolling a die. I know that I'm doing it 15 times, so n is 15. And I know that I'm either looking at a success or failure, success being rolling a 3. So the probability of success, that's P, is 1/6. And if I needed to know Q, which is the probability of failure, that's going to be 5/6 or 1 minus P. So the first thing I'm going to write is that, oh no, that's not the first thing I'm going to write. The first thing I'm going to say is let X be, I've got to define my variable. So for my first mark, what I'm going to do is first of all define my variable X. Let X be the number of threes in 15 rolls. And notice that this definition includes the number of trials, okay? Because a binomial distribution is defined by the number of trials, and therefore X is binomially distributed with n is 15 and P is 1/6. So that's so far the information that I've given. And now I can proceed to answer the questions. What is the expected number of threes? Well, E of X is n times P. Okay, so all I need to do here is go 15 times 1/6. It's going to be 5/2. I'm just going to leave that as a fraction. For B, I want the probability of obtaining more than the expected number of threes. So what that means is the probability that X is greater than the expected value. The expected value is 5/2, so I'm looking for the probability that X is greater than 5/2. Now, X can't actually be 5/2 because it's the number of threes in 15 rolls. 5/2 is 2.5. It can be 2 or it can be 3. 2 is less than this value. 3 is greater than this value. So that is going to give me the same answer if I calculate X is greater than or equal to 3. And that's what I'm going to use when I calculate this, and I'm going to do it in my CAS. So there's my CAS calculator. Yep, I'm going. There's my CAS calculator. So if you remember, I'm going to go to interactive. And now I'm not looking for the probability that X equals 3, but the probability it's greater than or equal to. So that means I want the cumulative distribution. So I'm going to distribution, I'm choosing discrete because it's binomial and binomial is discrete. And I'm choosing binomial CDF. Now I want to know the probability that it's 3 or more out of 15 trials. So my lower boundary is 3. My upper boundary is 15. I can't have more than 15 in 15 trials. Number of trials is 15. and the probability of success is 1/6. Don't try and write a decimal here, just write 1 divided by 6. Okay. And there's my answer. I don't need to show any more working than that. The working that I need to show, I have shown, and that's here when I've written probability of x is greater than 5/2, and then I've rewritten that as greater than or equal to 3. And now all I need to do is write in my solution, and I've got 0.4678. I've gone to 4 decimal places. The question didn't say it should have. Okay, let's go to the next example. Okay. So here's example 2. It is known that 5% of a batch of batteries are defective. A random sample of 80 batteries is taken with replacement. Find the expected value and variance of the sample. Now, when it says with replacement, actually, I don't know how many batteries there are in the whole, batch, right? But I'm taking a random sample of 80. I assume it's so big that really the replacement bit doesn't even make a difference. But what I do know is that when I take a battery, there are 2 possibilities. Either it's defective or it's not. So it might seem a bit weird that we are defining finding a defective battery as a success, but because we want to know the expected value and variance, that is what we do, because we're going to count number of defective batteries, and then the number of samples, n, is 80. So this is definitely a Bernoulli sequence, and therefore it's going to be binomial. So I need to, of course, define my variable. Let x be and you've got to do this properly. Don't skip it. Sorry, you can barely read that. That's my terrible scroll. Okay, x is the number of defective batteries in a sample of 80, and I know that x is binomially distributed, where n is 80 and p is 0.05. If you can't remember which order to write these in, just write binomial, p equals 0.05 and n equals 80, and that's all the key information. Do not write this with these the wrong way around, because that's not going to get you the mark. Okay, find the expected value and the variance of the sample. The expected value, I know, is found by calculating NP. So that's 80 times 0.05, which is going to give me, I think, 4. And then the variance, which I just write VAR of x, is n times p times q. So that's going to be 4 times q is going to be 0.95. And that's going to give me 3.8. That's all you have to do. Okay, find the expected value, find the variance, and we're done. So to sum up what we've done so far, we have standard deviation and variance are our measures of spread, and expected value is our measure of center. And we have 2 formulas. Now you are going to meet other formulas for other values of expectation and variance. These are the ones for a binomial distribution. So it's really important that you've got a summary somewhere with these under the heading binomial distribution, with a summary of what a binomial distribution is, so that when you meet a question, you can do the important steps of first identifying that it's binomial and then finding the expectation and variance and standard deviation when you need it. Okay.